Okay, welcome back to another video. We're gonna do another video just solving a system of equations using a matrix equation. So remember, when you are first doing this, you want to set up your matrix equation. So you've got your system of equations here. So you just take the coefficients on your variables and throw them into a matrix. You put the variables in a column matrix, just a matrix with one column, so x and y, and that should be equal to, you throw the answers on the other side. Okay, so that's our matrix equation for this system of equations. Okay, and so this isn't too bad, right? But now what we want to do is we want to multiply both sides by the inverse of this matrix here so that it will go away and we'll just get x and y equals some numbers on the other side. Okay, so we find the inverse, Okay, so to find the inverse, we take our matrix and we put the identity matrix next to it, right? So for this one, it's a 2 by 2, so we put in a 2 by 2 identity matrix, which looks like that. 1's on the diagonal and 0's on the other places. Okay. And now we do row operations, and we get this to look like the identity matrix. Okay. So how can we do this? Well, first off, we want to get a 1 in this position. Okay. And this is going to be kind of a messy one to do because in this column, the only things I have are a 2 and a -5. So I've either got to divide this one by 2 or divide this one by -5 or do something else clever. I think what I'm going to do is just divide the top row by 2 so that we can get a 1 up there in that corner. So I'm going to do 1/2 times that first row. Okay. And so what do we get when we do that? We get 1 there, 5/2 here, and that's why it gets kind of nasty, right? 1/2 here, 0, -5, -13. Okay. There is a way I think you could do this without getting fractions, but I don't really want to confuse you, so I'm not going to do it. Okay, so we got a 1 here. Now we need zeros below. So right now there's a 1 up there, so I'm going to use that to get rid of that 5. So that -5. So to get rid of the -5, I need +5. So I do 5 times row 1, and we're going to add it to row 2. Okay. So what do we get here when we do that? Well, 5 times row 1 is, this is 5, plus -5 is 0. So my first row is staying the same because we're not changing that. Oh, over here things could be different. Okay, there we go. Now 5 times 5/2 is 25/2 plus -13. Eesh. That's a fun one, right? Do maybe a little bit of scratch work. 25 halves, and we're going to be adding it to negative 13. So 25 halves minus 13. Well, 13, how many halves is that? We times it by 2 over 2. We get 25 halves minus 26 halves. We need a common denominator, right, to do this. So 25 minus 26 is negative 1. So it's negative 1/2. Okay? You could do that in a calculator as well if you wanted to. Okay? 5 times 1/2 is 5 halves. We're adding it down. So 5 halves plus 0 is 5 halves. And then 5 times 0 is 0 plus 1. Okay. Cool. So now we just need to get this to be a 1 and then this to be a 0, and we'll be done. Okay. So I'm going to start. We should make this a 1 first. Okay. So I'm going to make this a 1, it's a negative 1/2 now. So I'm going to times it by negative 2 so that I get positive 1. Okay. So I'm going to do negative 2 times row 2 to get our answer. So what are we going to get? We'll have 1, 0. The negative 2 times this guy is going to be positive 1 like we want. 5 halves times negative 2 will be negative 5. And then 1 times negative 2 is negative 2. Okay? And then the top doesn't change. It's just the same thing. Okay? So things are going really well. We're about there. So now the only thing we need to do here is we need to get rid of this 5 halves here. We need to make it 0. So I'm going to do negative 5 halves times this row so that I don't mess up the 1 that I have there, and then add it up. Okay? Ooh, there's my marker. So do negative 5 halves times the second row, and we're going to add it up to the first row. And there actually is a nice formula for computing matrices of 2 by 2 matrices that's in your book. I wasn't going to go over it just because I didn't want to spend the time on it, but you certainly can use it if you would like to. You can always do it with this method just fine. Okay, so negative 5 halves times the second row, and we're going to add it up to the first row. So negative 5 halves times 0 is 0, plus 1 is 1, so that's good. Negative 5 halves times 1 is negative 5 halves, plus 5 halves is 0. Yay, we've got the identity matrix. Okay, negative 5 halves times negative 5 is 25 halves, I believe. Yes, 25 halves, positive 25 halves. And we're going to add that to 1/2. So 25 halves plus 1/2, that's 26 halves, which is 13. Okay. Negative 5 halves times negative 2. The 2's will cancel on the bottom with that one. So we'll just get positive 5 because negative times negative is positive, and add it up. Oh, that's very nice. Okay. So our inverse here, the inverse matrix of this matrix that we started out with, the inverse is 13, 5, negative 5, and negative 2. Okay? So all I need to do to solve this equation is if I multiply both sides of the equation by this inverse, I will get what x and y are. Okay? So maybe I should move this, okay? So that we got some more space here. Okay. So I'll just write out the inverse again. Inverse was, we found out what it was. It was 13, 5, negative 5, and negative 2. So we've got our inverse. And so to get the answer for this system of equations, it's just going to be, when we multiply both sides by the inverse, we get xy should be equal to the inverse and times this matrix 220. Okay, so that should be what our answer would be. And it does matter which side you put the inverse matrix on, right? You can't switch the order of matrix multiplication. So on this one, to get rid of this matrix, I'm timesing by the inverse on this side of the matrix, okay? So I've also got to times on this side by that same matrix. So that's why it goes on the left of that matrix, okay? So what do we get when we do this? We get x and y is 13 times 2 is 26. 5 times 20 is 100. Negative 5 times 2 is negative 10. And negative 2 times 20 is negative 40. Ooh, those are big numbers. Hopefully I didn't just make a dumb mistake somewhere. Okay, so we've got 126 on top, negative 50 on the bottom. Okay. So what does that tell me? It tells me my answers. My answers are x equals 126, and my y is negative 50. Or if we wrote it as a point, it would be like 126, negative 50. Okay. So hopefully that kind of helps give you a better idea of how to do these with matrix equations. And I think that's the last video for this section, so good work on that. Let me know if you have questions on the homework. I'm more than happy to make a video talking about a homework question if you're unsure. Okay? I will see you later, guys. Have a good one.